Hello friends, here it is given that a particle moving in a plane describes r is equal to a e to the power theta cot alpha. So here it is given that a particle moves on a curve r is equal to a e to the power theta cot alpha. This is given, and the second information is given here. Angular velocity of the particle is constant. So angular velocity is constant, and angular velocity we know that this is d theta upon dt. Suppose that d theta is omega, d theta by dt is omega. This is the angular velocity. Here the angular velocity is given constant. We suppose that this constant is equal to omega. Now we find out here, show that the resultant acceleration of the particle. So for finding resultant acceleration of the particle, first we find here radial acceleration, then transverse acceleration, then find out resultant acceleration. So first we find here, for finding radial acceleration, first we differentiate one with respect to time. Because we know that radial acceleration is equal to d2r by dt2 minus r d theta by dt whole square. So d2r by dt2 we find from 1. So differentiate 1, we get here dr by dt. This is equal to a d by dt of e to the power theta cot alpha. Here a is the constant, so it is outside the differential operator. Now we differentiate this, cot alpha is also constant. So this can be written as d by d theta of e to the power theta cot alpha multiplied by d theta upon dt. Now when we differentiate this e to the power theta cot alpha with respect to theta, we get here a e to the power theta cot alpha multiplied by cot alpha multiplied by d theta upon dt. And we know that d theta upon dt, this is equal to omega, so we put here omega. You can see here this is equal to small r from first equation. So we write here r omega cot alpha. This is dr by dt. Now we again differentiate dr by dt with respect to time. So we get second derivative of r with respect to time. So this is omega cot alpha dr by dt. Because omega and cot alpha both are constant, so product of omega and cot alpha is also constant, so it will be outside the differential operator. Now this dr by dt, this is equal to r omega cot alpha, so we put here r omega cot alpha. So this is r omega square cot square alpha, so this is d2r by dt2. Now we find here radial acceleration, because we know that transverse acceleration is the square root of sum of the square of the radial acceleration plus transverse acceleration. So first we find radial acceleration. This is d2r by dt2 minus r d theta upon dt whole square. We know that the radial acceleration is d2r by dt2 minus r d theta by dt whole square. Now we put here value of d2r by dt2. This is r omega square cot square alpha minus r. And we know that this d theta by dt, this is the angular velocity which is equal to omega. So we put here omega. So we write here omega. Now we can see here this r omega square is constant. So we taking common r omega square and cot square alpha minus 1. You can see here this cot square alpha minus 1 can be also written as r omega square cos square alpha divided by sin square alpha minus 1. Now this can be written as cos square alpha minus sin square alpha divided by sin square alpha. Now this cos square alpha minus sin square alpha, you know that this is equal to cos 2 alpha. So r omega square cos 2 alpha divided by sin square alpha. This is the radial acceleration. Now we find transverse acceleration. So for finding transverse acceleration, we know that transverse acceleration, this is equal to 1 upon r d by dt of r square d theta upon dt. This is the formula for transverse acceleration. Here d theta by dt is the angular velocity which is constant, and this is equal to omega. So we put here omega in place of d theta by dt. Now we take common omega from this differential operator. So we write here omega upon r d by dt of r square. Now we differentiate r square with respect to time. So we get here d by dr of r square and dr by dt. Now we differentiate r square with respect to r. We get here 2r dr by dt. So r is cancelled out. You can see r is cancelled out. Now we r is cancelled out. So we write here 2 omega and put value of dr by dt. So value of dr by dt is r omega cot alpha. So this is r omega cot alpha. So this can be written as 2r omega square cot alpha. Now we find here resultant acceleration. This is equal to under root radial acceleration square plus transverse acceleration square. Now radial acceleration, you can see here the radial acceleration, you can see here the radial acceleration is here. Here the radial acceleration is, you can see this is r omega square cos 2 alpha upon sin square alpha whole square, and transverse acceleration you can see here 2r omega square cot alpha whole square. Now we know that here we can see this can be written as r square omega to the power 4 cos square 2 alpha divided by sin to the power 4 alpha, and here this is 4 r square omega to the power 4, and cot alpha can be written as cos alpha by sin alpha. So this is cos square alpha upon sin square alpha. Now we taking LCM here. So we write this is here the sin power 4 alpha, this is the LCM here. So r square omega power 4 cos square 2 alpha plus 4 r square omega power 4 cos square alpha multiplied by sin square alpha. You can see from the numerator we can take common here r square omega to the power 4. We take common here r square omega to the power 4 and sin to the power 4 alpha. We get here cos square 2 alpha plus 4 sin square alpha cos square alpha. You can see. Now we can see here this 4 sin square alpha cos square alpha can be written as 2 sin alpha cos alpha whole square, and 2 sin alpha cos alpha can be written as sin 2 alpha. So this becomes sin square 2 alpha. So this is r square omega to the power 4 cos square 2 alpha plus sin square 2 alpha divided by sin to the power 4 alpha. So this is equal to 1. We get here r omega square sin square alpha. So this is the resultant expression. This can be also written as r omega square cosec square alpha. Now we find radial velocity. We know that radial velocity this is equal to dr upon dt, and we know that dr upon dt, this is equal to r omega cot alpha. We know that radial velocity is dr upon dt, so this is r omega cot alpha. Now we find transverse velocity. Transverse velocity, and we know that this transverse velocity is here r d theta upon dt. This is r d theta upon dt. Now we know that d theta upon dt, this is the angular velocity. This is the angular velocity which is given constant, so this is r omega. Now we find here resultant velocity is equal to square root of radial velocity square plus transverse velocity square. Here we find out resultant velocity square. Resultant velocity, that is square of the radial velocity plus transverse square of the transverse velocity. Here the radial velocity is r omega cot alpha, so this is r omega cot alpha square, and transverse velocity is r omega square. Now you can see here this r omega square, r square omega square is common, so it outside the square root sign, and here cot square alpha plus 1. And we know that 1 plus cot square alpha, this is sine square cot square, 1 plus cot square alpha, this is cosec square alpha, and this is equal to r omega cosec alpha. So the speed v, speed is given here v. So v is equal to r omega cosec alpha. Now we have to prove here the magnitude of the resultant acceleration is v square upon r. This is the magnitude of resultant acceleration. So resultant acceleration is here r omega square cosec square alpha. This can be written as r square omega square cosec square alpha divided by r. Here in the numerator and denominator we multiply by small r. Numerator can be written as r omega cosec alpha whole square divided by r. And we know that r omega cosec alpha, this is equal to the resultant velocity. So here we can write v square divided by r. So we prove resultant acceleration is equal to v square upon r. Now we find the angle makes with the radius vector. So let us suppose that let beta be the angle makes resultant acceleration with the radius vector. So tan beta is equal to, tan beta can be obtained by the formula transverse acceleration divided by radial acceleration. Transverse acceleration divided by radial acceleration. So transverse acceleration is given by here, you know, transverse acceleration is given by here 2r omega square cot alpha. 2r omega square cot alpha divided by radial acceleration is given by here r omega square. You can see here this is r omega square cosec square alpha into cos 2 alpha. Cosec square alpha into cos 2 alpha. You can see here transverse acceleration is 2r omega square cot alpha, whenever radial acceleration is r omega square cos 2 alpha multiplied by cosec square alpha. So this omega square is cancelled by this r is cancelled by this, and this cot alpha can be turned to cos alpha divided by sin alpha, and this cosec square alpha can be turned as sin square 1 upon sin square alpha, and this cos 2 alpha. Now this is square cancelled by sin alpha, and 2 cos alpha sin alpha can be written as sin 2 alpha divided by cos 2 alpha. This is equal to 2 tan 2 alpha. So beta is equal to 2 alpha. Hence proved. Thank you.